All right, my apologies. It seemed that somehow the previous video recording got interrupted. I was laying out the rooms here for the home, and I'm trying to select up here. The button was getting in the way. All right, sorry. Okay, so that was getting in the way. Let's pull up this summary sheet. There we go. That's what we want. All right. Now, first of all, the reason why I wanted to do that is that right here, it shows the total area for the entire house. So in this case, we would have a nearly 3,200 square foot home. You would need to make sure that that the square footage is correct according to the architectural drawings, okay? Because if this is different, then all your numbers are going to be wrong. And of course, you'd want to do that for each room, okay? Similar to the spreadsheet, a more detailed example, or possibly a couple of videos, will be done for this software. I'm not going to go into the details here. This is meant to be sort of a brief overview. But what's important to us is this information that's on the bottom here, okay? We see that for the entire home, okay, for heating, we need 67,721 BTUH. This means BTUs per hour, or British thermal units per hour. And then for cooling, 25,497 British thermal units per hour. Now, what in the world are British thermal units? Okay, so we need to do a little bit of background from a science perspective. So energy, what is energy? Well, we sort of intuitively understand that energy is sort of like the potential to do things, okay? Now, energy can exist in a number of different forms. Kinetic energy is the energy associated with objects that are moving. Potential energy is the energy of an object that is not yet moving, but it can. So for example, let's say you've got a rock that's at the edge of a cliff, okay, 100-foot tall cliff, and there's a large, I don't know, 5,000 pound boulder sitting there at the top of the cliff. So if that rock were to fall off the cliff, it would fall down, okay? We sort of intuitively understand that the falling has a lot of energy associated with it, right? But right now, it is not falling, it is not moving, it's sitting there. So we call it potential energy, and that's based on the height, okay? And the weight, the mass of the object, okay? Now, another form of energy, there are a few forms of energy. Another form of energy is heat. Heat energy essentially is the amount of energy in a particular medium, right, meaning a particular type of material, and that is the energy associated with the atoms and molecules moving and vibrating internally within that material. So now, when you hold a piece of metal in your hand, it might feel solid, okay? I mean, it feels solid to you. But on an atomic level, if you had a microscope capable of zooming all the way in, you would see the atoms vibrating in place, and they are vibrating and next to each other and kind of bumping into each other. That amount of vibration associated with those atoms is what we call heat. Okay, so in air, the amount of air in a room or the air outside, okay, if it's a hot day, there's more heat energy, which means that the atoms, the molecules, are bouncing around really fast and they're all over the place. When the temperatures are cooler, there's less energy, and so they are still moving around and vibrating, but a lot less, okay, relatively speaking. So the British thermal unit is simply one way of measuring heat energy. Another unit you might hear of is joules, okay, and that's why it's called manual J, because in the world of thermodynamics or engineering, typically we use the international standard, okay, the SI unit of J for joules. I believe that's why it's called the ACA Manual J, even though actually here they use British thermal units. That's because here we're in the US and the US uses some really weird numbers. But anyway, I mean, they mix up watts with BTU and square feet and all that kind of stuff, even though watts is a unit that's part of the SI system. But we're not going to get into that right now. Anyway, down here, this is really what we're after. And this tells us that we need a heating system, okay, a machine that is capable of providing nearly 68,000 British thermal units per hour of heat energy. All right, and just to help sort of make this a little bit more concrete for some of us, okay, let's look here at the cooling. Okay, so we see that this particular home needs 25,000 BTUs per hour of cooling. So what does that mean? Well, some of you might be familiar with those window unit ACs. So let's head over to the Home Depot website, okay? And we see here that they've got a number of models available. And if we look at this one, for example, this one is, decently powerful. This window unit AC provides 12,000 BTUs of cooling, okay, for a room. So you would install this in a window, a relatively large window perhaps, okay? You wouldn't really use this for a bedroom. You'd probably use this for a dining room, let's say, or a living room area, okay? And it could provide 12,000 BTUs of cooling, okay? So theoretically speaking, 2 of them would be enough to cool this entire house. Now this is going to be to the specific location where this home is located. This software is currently running in a demo version, and so by default, this location that it has, it doesn't need much cooling, but that's because, actually, I just realized, I did not specify any windows or doors. I just have walls here and a roof. If I were to start drawing here windows, okay, that would change significantly. All right, so let's remember we had 25,000 BTUs for cooling. Now that I've put some windows, so windows are terrible from an insulation perspective, especially in the summertime. They allow in all that hot sunlight with all of that hot energy associated with the sunlight, all right? And of course, a window is going to have less insulation from, compared to a wall, right? Meaning the cold air is able to transfer its energy better compared to a wall. I'm sorry, that didn't make any sense. A window is going to allow the transfer of energy much better. Well, a window will allow more energy to transfer compared to a wall, okay? So now we've got 2 doors and we've got our windows. Now let's check our spreadsheet. And again, my recording toolbar up top is not letting me get to it, so let's click over here and we see that for the entire home, look at that, sure enough, our total load has increased significantly, and so has our heating load as well. Previously this was 25,000, now we're looking at nearly 39,000, okay? And this I believe was 65,000 before, and now we're looking at 83,000. This is actually just a great example of how when you're laying out all of the information of the home, whether it's in this software or in the spreadsheet that I showed before, I'm referring to this one, okay? It is very important to capture all of the correct information, not just how many windows there are and where they are, but also what's the exact size. So how tall is the window? How wide is the window? What's the separation between the top of the ceiling and the window, right? What kind of glass is the window made out of? All right, I didn't really cover that before. Let me do that real quick. So if I click here on this window, I right click to bring up the property sheet. No, there we go. All right, here we're going to specify the kind of window. Is it a single pane window? Not very energy efficient. Is it a double window? Okay, excuse me, double pane, now we're getting better. Triple pane, all right, even better. However, it's much more expensive. So, it's the law of diminishing returns that a triple pane window is not that much better than a double paned window, but it is more expensive. So kind of the best bang for your buck is a double paned window. But I suppose if you were able to find it for a good enough price, it might make sense to go with a triple pane window, all right? Now, all of this is important because it costs money and resources to heat or cool a home. So we want to protect our home in the best way that we can, okay? But also for a reasonable and affordable building cost, right? So yes, theoretically, we could perfectly insulate the home, but that would be, incredibly expensive. So there's a balance to be had that we want the cost of building to be, reasonable and affordable to the homeowner, but we also want to provide the homeowner with a good enough product in terms of insulation. Now, it also happens to be that there are building code requirements, and they are tailored to the specific region, right? So every city or county often has its own little tweaks to the building code, and they might say that, okay, in this region we require an R13 kind of cavity insulation, or if it's really cold, I suppose it's possible they could specify an R15, right? Or if you live somewhere where the weather's really nice, maybe they'd only specify an R11. Okay, um, but the building code generally does specify some of the basic minimums, and of course, a homeowner may choose to do better than that. All right, so that just about wraps up this video for an introduction into MEP engineering. We covered at a very high level mechanical, electrical, plumbing, meaning we talked about what's included in it, right? Basically, mechanical means things like heat and cold and our HVAC system. We talked about how electrical refers to electrical load calculations, okay? And plumbing refers to things like the piping and the water and the sewage. We will cover those in greater detail in future videos, and this wraps up the intro to MEP engineering with a little bit of an introduction into the mechanical side of things from the energy analysis. There is next, relative to mechanical, there's manual S, relative, and that is about how to select equipment. And manual D is how to design the actual ducts that carry the cooling and heating air. And those will come in future videos. Thank you very much. Have a good day.